Now, this is the third segment for the Module 2 lecture. In this segment, we're going to talk about the graphical displays to represent the frequency distribution for qualitative variables. So again, this is only for when you have the frequency distribution for a qualitative variable. And there are three possible displays. The first one is the bar chart. This is where the vertical axis of the graph displays the frequency, relative frequency, or percentage, and the horizontal axis displays the categories of the qualitative variable. And the height of the bars are proportional to the frequency or relative frequency or percentage, depending on what you're graphing on the bar chart. The Pareto chart is just a bar graph, except that the bars are ordered from the largest to the smallest frequency, relative frequency, or percentage, again, depending on what you are graphing on the Pareto chart. The last graph is called a pie chart. This is just a circle cut in slices like a pie, and each slice corresponds to a category of the qualitative variable, and the size of the slice is proportional to the magnitude of the frequency, relative frequency, or percentage, again, depending on which of the three you want to show on the pie chart. Here's an example that we talked about in the previous segment with data with the 10 students. So this is the frequency distribution of the grades for those 10 students. And in this case, I use Excel to produce the bar graph of the frequency of the grades. So you see a grade A has a frequency of 1, a grade B a frequency of 1 as well. C has a frequency of 5, D a frequency of 2, and you can see that, and F a frequency of 1. So we can say that this graph, that this bar graph shows that the most common grade is C, since it was assigned to 5 of the 10 students, and also 2 grades are above C and 3 grades are below C. So this is one way to explain the graph in simple terms. Now here's the Pareto chart. So as you can see, it's the same graph. Again, I produced it using Excel, and Excel does not leave a gap between the bars. But in this case, I'm plotting the frequency, and so C, because it was the most frequent grade assigned, the frequency of 5 is the first bar. D is the second most frequent grade assigned with a frequency of 2. And then A, B, and F have a frequency of 1. Typically, the Pareto chart shows a line which represents what is called the cumulative percentage. So I put this column where I show the cumulative percentage. And so we take the percentage of the first category, right here, 50. Then we add the percentage of the second category to the first category, and we obtain the cumulative percentage of the second category. So between C's and D's, we have 70% of the grades. Then the next category is A, and then it's 10%. So we add the 10% to the 70%, that gives me 80%. 10 plus 80% gives me 90%, and 10% plus 90% gives me that 100%. The advantage of this is that the Pareto chart shows you very quickly which is the more frequent categories, and you can use the cumulative percentage line to draw some conclusions. For example, the cumulative percentage line in the Pareto chart shows that 50% of the students obtain a C, and you can see that this line starts at C right here, 50%. So this is the percentage category. And then if you take the percentage of C and D, so this is 70%. Now, F is the only grade that is below C and D. So if I take the 10% that corresponds to F, then I can say that 80% of the students obtain a grade of C or lower. And that immediately tells you that in this class, well, there were not very many high grades. In fact, only 20% were grades above C, that is A and B. So again, this is the Pareto chart. again, is just a bar graph, but the bars are in order. And typically, the cumulative percent line is shown on the graph. Now, here's the pie chart for the example with the 10 student grades. Now, in this case, again, I use Excel to produce this graph. Here's the key and the color. So the gray is C, and you can see that it's half of the pie because 5 of the 10 grades were C. And then these about right here is 20%, and these wedges are the same size because this is a frequency of 1. And the numbers in each of the wedges tells you the frequency. So again, you can be presented with this graph, and you will interpret it by saying that this pie shows that 5 out of the 10 students receive a C, 2 students obtain a D, and since only 1 student obtain an A and 1 student a B, well, we could think that this was a difficult course. Or maybe it's not such a difficult course, but the professor was a difficult person. We don't know. We need to investigate further. But just the distribution of grades that you see, or the frequency distribution of the grades, gives you a clear picture that this was not an easy class. Now, here's the bar graph for the other example that we talked about earlier, where we were asking the workers whether if they were stressed in their work. You might remember that we said that 33.3% of those workers felt that they were very stressed, 46.7% felt that they were somewhat stressed, and 20% they were not stressed at all. So now this bar graph, instead of showing the frequency, now it's showing the percentage. And you can see right away from here that about 33% were very stressed, near 50% were somewhat stressed, and 20% were not stressed at all. So if you were presented with this graph, you could explain it by saying that in this company, 80% of the employees are either very stressed or somewhat stressed, and only 20% do not experience any stress. So again, this is the bar graph for our second example. And this is a pie chart for this example of the level of stress. And in this case, I took advantage that this was a very small frequency distribution, and show you how the wedges of the pie are drawn. So now you know that there are 360 degrees in a circle. So we use the relative frequency and multiply that by the total number of degrees. And that gives me the angle for each of the slices. So 0.333 times 360 is equal to 119.88 degrees. So we will use a protractor and draw a circle. And using that protractor, we'll find an angle of 119.88 degrees, and we mark the lines of that given from the protractor. Then for the somewhat category, we multiply 0.467 times 360 degrees, and that gives us an angle for the slice of 168.12. Again, we'll use our protractor and draw that angle. And of course, whatever is remaining in that circle, that wedge, is going to be to the third category, where the people are not stressed at all. And if you want to, you can multiply the frequency by the total number of degrees, and that gives you 72 degrees. So this is how you would draw a pie chart if you were to do it by hand. Of course, we tend to use software to do this. So again, you can interpret this pie chart as one way is to say that in this company, 46.7% of the employees are very stressed, and only 20% do not experience any stress. Now, the last example, the larger data set that we talked about, that's data set with 2020 data observations. And in here, we're applying the percentage by the categories. In here, this is not a Pareto chart. It looks like a Pareto chart, but Excel is going to order the categories in alphabetical order. So New York appears before Paris, and Paris appears before C. But from this graph, you can see that about 50% of the transactions occur in New York. Near 25% of the transactions occur in Paris and Sydney. So when, let's say this is a graph is presented to you in the exam and is asking you to explain this graph, well, you could say that what you said, 50% of the transactions occur in New York, and about 25% of those occur in Paris, and 25% in the Sydney branch. So that could be an answer to this question right over here. All right, so this is the end of the third segment. In the next segment, now we're going to talk about summarizing data from a quantitative variable.